We're going to use the L'Hopital rule to justify that the limit of x squared minus 1 over x minus 1 equals 2. Put it another way, we will use the L'Hopital rule to find the limit. To do that, first we see that the numerator and the denominators are functions that are differentiable. And then, to check the condition, we also take the limits of the numerator and the limit of the denominator to see if it is 0 over 0. But since both the numerators and the denominators are continuous, we can just simply plug in the value x equals 1. In the numerator, 1 squared minus 1 is 0, and in the denominator, plug in 1 minus 1 is 0. And so, we can use the L'Hopital rules. The L'Hopital rule states that to find the limits of the ratio that is of the form 0 over 0, which is indeterminate, we simply differentiate the numerator separately. The derivative of x squared minus 1 is 2x, and we differentiate the denominator separately. The derivative of x minus 1 is 1. And then treat this as a new limit problem. This is the limit of x goes to 1 of 2x, and if we plug in 1, we get 2. So the answer is 2. For the limit of the square root of x minus 2 over x minus 4 at x goes to 4, we see that the numerator is a continuous and differentiable function, and the denominator is also a continuous and differentiable function. To check the condition of the L'Hopital rule, we take the limit of the numerator and the denominator separately, but since they are continuous, we could just simply plug in the value and evaluate the function. The numerator is the square root of 4 minus 2, which is 2 minus 2 or 0. The denominator, plug in 4, we have 4 minus 4, which is 0. And so this is the limit of the 0 over 0 form, which is indeterminate. To use the L'Hopital rule, once we check the condition that it is satisfied, we take the derivative of the numerator and the derivative of the denominator separately. In the numerator, the derivative of the square root of x is 1 over 2 root x, and the derivative of minus 2 is 0. In the denominator, the derivative of x is 1, and the derivative of 4 is 0. This is not the quotient rule, but a L'Hopital rule. And then we simplify this. At x goes to 4, the numerator is now 1 over 2 root x, and the denominator is simply 1. So this is the limit at x goes to 4 of 1 over 2 root x. We then treat this as a new limit problem. How do we find this limit? Since this is a continuous function, we just simply plugged in the value of x. So this is 1 over 2 root 4. And square root of 4 is 2. So this is 1 over 2 times 2, which is 1 over 4. And that is the answer. For the limit of x goes to 0 of sine of pi x over sine of ex, both the numerator and the denominator are continuous trigonometric functions. To check the condition of the hypothesis of the L'Hopital rule, we find the limit of the numerator and the denominator separately. But again, since this is a continuous function, we just simply plug in the numbers and evaluate the numerator and the denominator separately. Sine of 0 is 0. Similarly, in the denominator, sine of e times 0 is sine of 0, which is 0. And so this is the limit of the form 0 over 0, which is the indeterminate form. And since both of these, numerator and the denominator separately, are differentiable, we can use the L'Hopital rule. We state that to take the limit using the L'Hopital rules, one, the condition is satisfied, we simply take the derivative of the numerator and the denominator separately. In the numerator, the derivative of sine of pi x is, using the chain rule, cosine of pi x times pi, pi being the derivative of the inner function pi x. In the denominator, it is cosine of ex times e. And then we treat this as a new limit problem. Pi and e are constant multiple, so we would factor pi over e to the front of the limit. And again, we treat it as a new limit problem. This is a continuous function where the denominator is no longer 0 if we plug in 0 at x equal to 0. We have pi over e cosine of pi times 0 over cosine of e times 0. And so this is pi over e. Cosine of 0 is 1. The answer is pi over e.